So far we have discussed about the other algorithms. Now in this lecture we are going to read about round robin scheduling algorithm. So the round robin scheduling algorithm we are going to discuss, which is very important scheduling algorithm, and that is the round robin scheduling. So we'll see what is round robin scheduling and how it works. The round robin scheduling algorithm is designed especially for time sharing systems. So why it is designed for time sharing systems we will understand as we move ahead, and it is similar to the FCFS scheduling but preemption added to switch between processes. So this round robin scheduling algorithm in one way is similar to the first come first serve scheduling, but preemption is added to switch between the processes, and we will be seeing how it is done as we move ahead. So here is a small unit of time called a time quantum, or a time slice is defined, which is generally from 10 to 200 milliseconds. So in this round robin scheduling, what happens is what we define a small unit of time, which is usually called the time quantum or a time slice, and this time quantum or time slice is generally defined from 10 to 100 milliseconds. So it will be for between 10 and 100 milliseconds, and what happens is that each process will be assigned this time quantum for its execution. So whether the CPU burst of the process is greater than the time quantum or does not matter, but this specific time quantum is assigned to each process, and the process will be allowed to execute only for that particular time quantum in the first round, and after that the CPU will be given to the next process that is waiting in the ready queue, and that process also will be allowed to execute for that specific time quantum, and then the CPU will be given to the next process, and so on. So what happens is the ready queue is treated as a circular queue, and the CPU scheduler goes around the ready queue allocating the CPU to each process for a time interval of up to time quantum. So that is what we have explained. What will happen is the ready queue is where the process are waiting is treated as a circular queue. So I have shown this using this diagram over here. So think of this as a circular queue. So this is the ready queue, and the process are waiting in this circular queue, waiting for its turn to get the CPU for its execution. So here we are having 10 processes P1, P2, P3 up to P10, so that they are waiting in this queue, and when a new process comes they will be added to the end of the queue or at the tail of the queue. So this is process P10, which is the last process. So if a new process arrives, it will be added after this P10 at the tail of the queue. So you may not be able to visualize the tail of the queue because it is circular over here, but actually it is not circular in shape, but just to make you understand, I have shown it in this diagram. It is actually just a normal queue where the CPU scheduler will move from one end of the queue to the other end, and then come back to the start, and again move from the start to the end, and it goes on like that. So that is why we have taken today using a circular queue. So we have a process P1 to P2 waiting in the circular. A ready queue is waiting for getting the CPU for the execution. So what happens is there is a CPU scheduler that will assign the CPU to this particular process. So first of all, the CPU scheduler will come and assign the CPU to the first process that is there. It is in P1. So in this way it is going to start like a FCS scheduling, first come first serve. So whoever is first will be given first the CPU, and for how long will it be given the CPU? It will be given the CPU for a particular time quantum. So there will be a particular quantum of time that is we define, and only for that amount or period of time the CPU will be assigned to a particular process. So let's say that the time quantum here is 5 milliseconds. So what will happen is the CPU will be given to P1 for 5 milliseconds. So P1 gets a CPU and uses it for 5 milliseconds. That is one time quantum. So after that the CPU scheduler will come and give the CPU to P2, which is next process that is waiting in the circular queue. So P2 will get the CPU and will also be allowed to execute for 5 milliseconds, which is a particular quantum of time, and after that P3 will be given the CPU and will be allowed to execute for 5 milliseconds, and so on. It will go around like this in the circular queue, and when it reaches the end of the queue, what happens is that it will again come and check if P1 has completed its execution or not. So if P1 has completed its execution, then P1 does not have to get the CPU again, but if P1 did not complete its execution, in the first quantum of time that it has received, then the CPU will again give back the CPU to P1 and will be allowed for execute one quantum of time, which is 5 milliseconds in this example we are talking about, and then it will go on like that for other processes.